Okay, so we are going to introduce polynomials, and today is all about classifying them and being able to just recognize the different terminology that goes along with polynomials. And this is not something that you're going to be assessed on, but it is considered building blocks for everything that we are going to be doing in the next couple of levels and the next couple of units. So a polynomial is two or more terms being added or subtracted together. So here is an example of a polynomial. We can see that this is both being subtracted and added, which means that these individual things between the addition signs and the minus signs are terms. So this one technically has three terms, and terms are separated by pluses and minuses, which you'll need that for one of the homework problems. This is an example of something that is not a polynomial because there are no pluses and minuses, which means that this is just a single term. This is also a single term. Single terms are called monomials. So the prefix is mono, meaning one, as opposed to poly, meaning multiple. You would see that for polygrams, or in biology, they use the word poly to represent like multiple chains of like sugars and things like that. So here they're separated by pluses and minuses. So this is a polynomial because it has three terms, and three is either two or more. These are just single ones. And they're known as monomials. Next, we want to be able to classify the degree of a polynomial. The degree of a polynomial is the largest degree of an individual term. The degree on a term, that's worded funny, is when the exponents are added together. So if there's only one exponent, so first of all, we only care about the ones that are on a variable. So m is our variable and its exponent is 8. So the degree is 8, and we could say this is an 8th degree term. This, the x, has an exponent of 10, so its degree is 10. Here, we still don't have pluses and minuses, so this is a single term. And if we add those exponents together, 3 plus 2 equals 5, so this is a 5th degree term. We only do that when there's more than one variable in a single term. Here, though, we have a plus sign, which means this example has two terms. Again, if I'm going too fast at any point, don't forget you can hit pause, you can rewind, you can listen to it again, and I recommend doing that if it doesn't make sense. So we have two terms. We have this one here and this one. So going back to the definition, it's going to be the largest degree of an individual term. This term is to the 4th degree. This one is to the 3rd degree. Since 4 is larger than 3, then we're going to say it's a 4th degree polynomial. Here we have pluses and minuses, or technically we just have two plus signs. So we have 3 terms in this example. And because there's multiple variables in each term, we have to add their exponents together to find out what degree they are. 3 and 2 makes 5, so this term is a 5th degree term. The exponents here are 1 and 1, so this is a total of 2. And here we have 2 and 1, which is a total of 3. So a 5th degree, 2nd degree, and 3rd degree. The largest degree is a 5, so this is a 5th degree polynomial. This one has 4 terms. Again, if it has 2 or more terms, it's considered a polynomial. So these are all examples of polynomials. These were all examples of monomials, which we're going to use this terminology a lot in level 1, level 2, and level 3. So again, you're not being assessed on this, but it does help if you understand these words, which the more you practice today's lesson, the better it'll get. So here I have an exponent of 3, 2, 1, and if nothing's there, it's like the variable is to the 0 power, because we know anything to the 0 power is 1. And so the largest degree we have here is 3. So this is a 3rd degree polynomial. Hit pause if you need to. Standard form is when terms are in descending order. Okay, so that means that it's going to go down according to their degree. So here's an example of a polynomial that is not in standard form. So if I look at the degree of each of these terms, we have 1, 4, there's no variable there, so the degree is 0, and 3. If I want to put this in standard form, I need to start with the largest number and go to the smallest order. That's what descending means. It means go from large to small. So the largest degree here is this, and I'm always going to take the sign directly in front of it. That means that this is a positive 4x to the 4th, so I'm going to lead with a positive 4x to the 4th. The next largest term is here. I'm going to take the sign in front and write minus 8x to the 3rd. Next largest, 0 and 1, that would be 0. In front of this is nothing, which implies it's positive. So I'm going to write plus 9x. And then finally, minus 10, our constant at the end that was a 0 power. Now this is in descending order because it goes 4, 3, 1, 0. The leading coefficient is the coefficient of the first term if the polynomial is written in standard form. So here I have an example of a polynomial that is in standard form because it goes 3, 2, 1, 0. And the leading coefficient is the one that's at the very front. The coefficient is always a number in front of a variable, but the leading coefficient is the very first one if it's in standard form. So the leading coefficient here is 10. What's the leading coefficient of this one? If you said 4, you are correct. Okay, on the next page. This is a review of what we just talked about. So what I would like you to do is attempt each one of these, put them in standard form, and then flip to the previous page if you need to help you identify what the degree and leading coefficient is. Go ahead and hit pause and do that now. Here are your answers. So hit pause and check all of your answers and determine, do you have any questions? If there is nothing in front, it's implied to be a 1. Next, at the bottom of this page, we have special names. Sorry, I've taped my phone to this document camera because the audio decides when it's going to work. And now hold on, technical difficulties. What is happening here? Give me 30 seconds to sort this out. Add more tape. Make this more awkward. Okay, now let me figure out where we're at. Okay, still recording. All right, so special names is basically, can you identify the degree and figure out what the name associated with that degree is? Can you identify the number of terms and figure out what the name associated with that is? So can you read this chart? So this one's talking about degree. And when it comes to degree, the words I'm going to use in this class are constant, linear, quadratic. I'm very rarely going to talk about cubic because I don't think we actually get to that function. These are the different families of functions that we talk about. We spent Unit 4 talking about linear, Unit 8 is quadratic, and these other ones we don't necessarily get to. And then the number of terms, I'm going to use these three words constantly. I'm probably going to use the word polynomial as well, but just know that if it's two or more, a binomial is technically a polynomial, a trinomial is technically a polynomial, because a polynomial is two or more, but a lot of times when we talk about two, we use the word binomial and trinomial quite frequently, and those are the words I'm going to use moving forward with the next level, or this level, I guess. So what I'd like you to do is try to see, can you identify what the degree and the number of terms are, what the names are. So for example, the degree on this one, this is to the first, this is to the 0 power. So the largest degree is a 1. And so when I come up here, that means that this is an example of a linear function, which should make sense because that looks like y equals mx plus b, right? And how we identify it's linear is because it's to the first power. The name based on the number of terms are separated by pluses and minuses. So there are 2 terms here, which means that this is a binomial. Okay. Next, the largest degree here is a 2, because this is 2, 1, and then technically 0. Oh, that should be a y to the 0. And so if it's a 2, that means it's quadratic. And how many terms are there? 1, 2, 3, which means it's a trinomial. Can you figure out the next one? Hit pause for a second and do it. The degree is a 7. That's the largest degree, which means we're going to call it a 7th degree polynomial. And it's got 1, 2, 3, 4 terms, which means we're going to call it a polynomial. All right, so hit pause if you need to. Otherwise, let's flip to the next page. This is review. Can you combine like terms? A like term means it's got the same variables with the same powers. So hit pause and see if you can combine these like terms. Here are your answers. Check them carefully. Hit pause to check them. So some issues you might have with these answers is this one specifically. PM, this says 6 times P times M. This one says 6 times M times P. And what I want to emphasize is that when we're multiplying things together, the order we multiply them does not matter. So if I had 6 times 1 times 2, it equals 12. But if I changed the order and said 6 times 2 times 1, it's still 12. So these are like terms because they both contain P and M, and they're both to the first power. So we can combine them, and together they make a 0. And so our final answer is here. I am writing these to the best of my abilities in standard form. However, you'll notice that this one and this one are kind of tied. They're both 2 degree or 2nd degree terms. So whichever one you put first, normally we go with alphabetical order, but I'm fine with whatever one you put first here. And the same thing goes with these. These are both 3rd degree terms. So whichever one you put first is your choice. Okay, and then the bottom, what I'm going to have you do is practice. See if you can figure this out. Can you combine these like terms, write them in standard form, identify the degree of the polynomial, and what is the leading coefficient? So hit pause and do that now. Do not just hit play and copy what I write. Try to figure it out for yourself. So hit pause. Here are your answers. Okay, I've highlighted like terms. I've put them in descending order, 2, 1, 0. So the highest degree would be a 2 for the second power, and the leading coefficient was a 9. Okay, so if you have questions about that, make sure that you ask.